Okay, hopefully this pen works. Um, so I wanted to show something relatively practical in the number system that I outlined the other day. So looking at the fundamental circle constant, which is not pi, it is 1/4 of pi. So have a different symbol for that, which uses circle inside a square for our symbol for the fundamental circle constant, pi on 4. Not to be confused, apparently, with taking pi and dividing it by 4 every time you're working with circles. That's... Focus, you piece of shit. Hello. That's not what we're doing. We're not taking pi and dividing it by 4 just to produce more work, like some retarded bastard in my comment section believes. That's not what we're doing. It's the actual fundamental circle constant. Just like tau is 2 pi. It is a different claimant to the throne. When you're using tau, you're not going around multiplying pi by 2. You're using 6 point whatever. Right? That's what you use because you believe that tau is the fundamental circle constant. When you're using pi on 4, you're using 0.785. Not pi. And the reasons to do this are numerous, as I've explained, but you people are stupid, so you don't comprehend when I speak, and then you say that I'm mean when I point out that you're not paying attention. So, whatever, I'm over it. I'm not going to try to be nice about this anymore, because why? You guys are idiots. Okay, so, pi on 4. 0.785398816, whatever, in decimal. So let's look at it in this 60 by 60 by 77 by 52 base. Okay. So we take the pi on 4 value, 0.78539, right? We take that value, and we want to find out of 60, how much is that? So it's 47 point, and then it goes on 1, 2, 3, 9, whatever. So I want the 47 part. I want the integer part. Okay, so we've got 2 20s, a 5, and 2, so 47. And that is out of 60, as we indicate with this guy. Okay, so now we want to subtract off the 47. Come on, computer. And now that remaining part, which is 0.1239, it's only showing me 4 decimal places. I'm sure it's probably not a 9, it's probably like 87 or something. Who knows? It's 889. Okay, there you go. So I want to take that part and again multiply it by 60, and we're going to get a 7. So already 7/60ths is a pretty small fraction. 7/60ths is like just over a tenth. It's like about a ninth of, right? So, okay, we've gone pretty small. Now let's take off that 7, and so our next part is going to be out of 77 here. So I'm going to multiply the resultant 0.4334 by 77, and we're going to get a 33. So that's easy. It's 30 in base 77, which is our base 77 is the 3 is indicating 11s, so that's the value of that is 33. The new right, and that is in our base 77. Okay, so we're going to subtract off on our calculator the 33 part, and now we're in base 52. So that's going to be 19. So 1, like 10 in our base 52 thing is really 13. So I have this, and then I'm going to have 6. So that's 19, and then we're done with that cycle. So now subtract off that 19, and again multiply by 60. And now we're at 17, which is gonna just be 2 and 15 minus 17 times 60, 11. So like that, and then take off the 11 and multiply that by 77, and that gives me a 24, which is like this, 22 in our, so this is two 11s, which is 22. Add 2 more to that, we get 24. Minus 24, and then times 52. So that gives us 10, which is less than our base of 13. So that's actually, but so we're counting up to 13. So what we're actually doing is we're pairing 6s to get to 12. So you're going to get a 6 and then a 4 added to that. So there's your 10. And then there's more to it. So it's bigger than this, but that's 1/4 of pi, pi on 4, the fundamental circle constant, represented in the number base out to pretty substantial. So let's take this back. Let's take this back to how close does this get us to pi on 4? So I have 10 50-seconds. Okay. Let me see. That got us pretty. Okay. So 10 50-seconds. And then we're going to see. Just thinking, what is the correct order to do this? Going the other way was easier for me. Okay, so what I did here, let's see, I multiplied by 60, and then I subtracted what I got. Okay, so I want to now add, yes, okay, so that is 24, so I'm going to add 24, whoops, add 24 to this, and then divide by 77. Yes, okay, and then add 11 and divide by 60. And then add 17 and divide by 60. And then add 19 and divide by 52. And then add 33 and divide by 77. And then add 7 and divide by 60. And then add, what is this, 20 or 47? 47 and divide by 60. And that gave me, in decimal, whoops, this gave me in decimal 0.78539 8163397447185. This is why I'm using a computer for the calculator and not a calculator, because it'll give me mad precision. 86574. I'm not sure how far I need to go out, so I'm going to go out further than I need to. 257022648, and then it's 29, but I'm going to do 3 there because I'm pretty sure that's more than far enough. Okay, so now compare that to pi on 4. What is the value of pi on 4? So pi on 4, which equals our fundamental circle constant, is, in decimal according to the calculator, 0.7853986 33974 483. So it's at this point. So we've got that level of precision here. In decimal, that took us, well, counting the 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimals. And then that 16th one is actually not far off. Like, it's not very bad. It took us 15 of those, but really here, it took us 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is, if you learn how to do something like this, it might not be a bad way to think about numbers. But I'm sure somebody's going to go into the comments and say something fucking retarded, like always happens. And be like, and I'll get like a billion dislikes on the video. Because you idiots don't understand. You're incapable of listening. You're incapable of paying attention and understanding what I'm saying. And you go in and like, it's not entertaining enough. It's not fun. I don't get it. You're mean. Yeah, well, fuck you.